Good morning, Fayetteville High School. Welcome back, and I hope everyone enjoyed their break. Today is Wednesday, January 4th, 2023. Will you please join me for a minute of silence? Thank you very much. Will you please stand as you are able for the pledge? Allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you very much, and have a great day.
All right, welcome back. Hope you all had a nice, restful break. I know it's been a while, but if you did not notice the book sign or the handout up front, you do need that this morning, so please go and grab that. You will also need a calculator, so if you need to borrow one, please come and get that. But we're going to start off with a quick little semester overview here, because our second semester is quite a bit different than our first semester. So I wanted to just kind of highlight the changes, make sure you're aware, and take full advantage of that. But, of course, first semester for us is almost entirely all trig. So we started off diving into radians early on, and then unit circle, and then SOHCAHTOA, and then we did tons of different questions using those skills. Of course, a few other things as well, but all of it was kind of built upon that. Second semester has almost no trig involved. We will still hold you accountable for the unit circle, but short of that, you know, trig identities, inverse trig stuff, there's very little that carries over from first semester to second semester. Very, very, very little. So most students usually think second semester is a little bit easier. We do a lot more algebra stuff. So kind of our plan for the semester is we're going to spend just a couple classes on what we're about to move on into, and I'll talk about why we're only spending a few classes there. Then we'll spend a couple weeks on something called limits, which is actually the first calculus topic, whether you take AB next year or you choose to take calculus in college. Limits is always the first thing you start with. So that's meant to kind of show you a little bit of what calculus is like, but also make it a little bit easier if you are taking that next year. And then pretty much the rest of the semester is algebra review. So we spend 3 or 4 weeks doing exponentials and logarithms, which you saw in Algebra 2, but what you saw in Algebra 2 is more of an introduction. Whether you do calculus or college algebra or any of that kind of stuff, logarithms are a big deal, and so you need to know those well, which is why we spend a lot of time on those. We'll spend a couple weeks on rational functions, which is 95% the same thing you saw in Algebra 2. We'll spend probably a day or two on polynomials, which will be 95% the same thing you saw in Algebra 2. So for most students, they think second semester is easier, but a lot of it just kind of depends. If you learned it in Algebra 2 and then how much of it you remember. If you remember the majority of it, then second semester is really pretty easy for us. But if you didn't learn it in Algebra 2, or you learned it and forgot it, then you will have to relearn it, and hopefully it comes back to you quickly. But and Cooper, make sure you grab the handout in the book, please. But I will say, of course, not everybody's grade is higher second semester than first semester, but on average, it's usually about 5% higher. So if you put in about the same amount of effort as you did first semester, you should expect about 5% higher on average. That's typically how it goes. Okay, so what we are going to be doing the first couple of days, and we're only going to spend a few days on this. This is section 6.1 and 6.2. That's what handout you picked up, so please number that as 58. So notice I do continue on with the binder numbering. However, I will not ask for anything from first semester here in second semester. So what I would recommend you do is either buy a new small binder for second semester, or just take all of your stuff out from first semester and leave it at home safe, and at the end of the year you can put them all together if you want to. But I would not recommend that you carry around all of your first semester stuff with you all the time, unless you just really want to. But we will continue on with the numbering, so go ahead and number this one as 58. And this is a topic that you will do if you ever take a college trig course, but it is not a topic that helps with college algebra, and it's not even a topic that really helps with calculus, but we do like to give a couple days to it because this is one of the most common ACT topics that shows up anymore, and it is the law of sines and law of cosines. So first off, here is the law of sines. This is the formula typed up there for you. This and this are really the same formula. It's just that each one has they took the reciprocal of each side. So they're really the same thing. But I tend to use this one when finding a side length, because it's already in the numerator. Remember, lowercase abc would be side lengths. And then I tend to use, or start the formula off looking like this if I'm finding an angle measure, because I really want that sine A, sine B, or sine C to be in the numerator. It's not that you have to do that, it's just that it's going to take you an extra step or two if you don't do that. But they're really the same formula. Now, for this section, we do not even make you memorize the formulas. We will put them on our quiz so that you don't have to memorize them. This one is super easy, and after you work 4 or 5 of these, I think you'll know it, and you'll probably remember it forever. But we do expect that you know when you can use law of sines. So the when is when you have any 2 angles and 1 side length. In math, sometimes we abbreviate that as angle, angle, side, or angle, side, angle. Both of those have 2 angles and a side. And then this one, sometimes you can work with 2 side lengths and 1 angle that is opposite a side. I'll say given side. This is called SSA, side-side angle. So 2 sides at an angle, but the angle has to be across from one of the sides that you know. This one is kind of tricky. This is actually called the ambiguous case. If I gave you two side lengths and an angle, and the angle was opposite one of the sides, it doesn't guarantee a unique triangle. So if you guys remember geometry, you remember kind of hearing angle, angle, side, remember talking about that kind of stuff? All right, so some of these guarantee that you have one unique triangle. So these guarantee you have one unique triangle, but side angle was not one of those. So depending on how big the sides are and depending on how big the angle is, you could have no triangles, one triangle, or two triangles. And as of 2 years ago, we used to make students learn the ambiguous case. It takes about an extra day. It's not that it's hard, it's just it's kind of wordy because there's like 4 different things you have to check for. But again, our purpose in even doing this topic is to help you with the ACT, and this doesn't show up on the ACT, so we are not going to hold you responsible for this. Now, we will put like one question on our quiz that is going to be like a bonus. So if you want to learn about the ambiguous case, there's a little video here that you can watch, and I'll put this back up later, so you can decide if that's what you want to do. Now, I will say if you do take a college trig course someday, they will show you the ambiguous case and expect you to know the ambiguous case. We are cutting that out just so that we can not rush quite as much, and it's not on the ACT. Okay, so a couple of examples of it being used that have already been typed up. So someone's got this triangle set up here, and they're wanting to find side x. So notice they plugged in the stuff that they had. They put 10 and the sine of 48 together as a ratio, and then they put x and sine of 55 together as a ratio, and this is set up nicely because our formula only has one unknown, so then you just need to solve it. Looks like they multiplied both sides by x to get rid of fractions, and then undid times with divide, and then from here to here they just threw it in the calculator. Very easy formula to use. Oh, I didn't say this, but what is unique about this that makes it very powerful compared to what we did last semester is all the Pythagorean theorem, SOHCAHTOA stuff that we did last semester only works on right triangles. Law of sines, law of cosines works on oblique triangles. Oblique triangles are triangles that don't have a right angle. So there's lots of right triangle stuff naturally occurring in the real world, but there's even more non-right triangle stuff. So law of sines and law of cosines is even less restrictive. It always works. Okay, and then over here, here's an example of someone using the law of sines to find an angle measure. So notice they paired up the sine of x with 12 as a ratio. They paired up sine of 42 with 22 as a ratio. You got to use the ones opposite each other. And then they undid divide 12 by multiplying both sides by 12. And then you probably need to highlight or mark this right here. Once you get sine x equals, that's not the same thing as what x equals. There's a big difference. Remember, sine can be as small as -1 or as big as +1. You don't have to know that this semester, but it does help you understand why this is not the angle. To go from sine x equals to just x equals, you need to do inverse sine of that number. So when you go and practice a few of these questions in the book in a minute, if all of your angles seem very small, it's probably that. It's probably that you're not doing inverse. But assuming your calculator's in degree mode, type it in, hit enter, and it will do the rest. So basically you need 3 of 4 numbers. You got to plug them in the formula that you don't even have to memorize. You've got to solve the formula, and then you got to make sure you know how to type it in the calculator. So it usually only takes a couple of those for you to figure that out. Okay, then also law of cosines. I will write all 6 of these on your assessment for you so that you don't have to memorize them. But these guys are good for finding a side length. If I was trying to find A, B, or C, I would use those 3. And then these 3 are set up great for finding an angle measure. If I wanted to know angle A, angle B, or angle C, I would use the top, middle, or bottom. And again, since you don't have to memorize them, it's really just a matter of knowing when you can use it and making sure that you can put it in your calculator correctly. as I said, we will ask you when to use each of these, but I feel like on this one, it's really not that much of a mystery. If I'm trying to use one of these formulas, let's say I was trying to find A here, I'm going to need to know a side length, another side length, the first side length again, the second side length again, and then angle A. But if these are B and C, A would be the angle in between these. So this would be 2 side lengths and their included angle. Included just means it's trapped in between them. So the shorthand would be side angle side. If I wanted to use one of these, if I'm trying to find angle A, angle B, or angle C, any of these I look at, I have to know all 3 side lengths. Or side, side, side. So law of sines works anytime you have 2 angles in a side, and it sometimes works with side, side angle. Law of cosines always works for side angle side and all 3 side lengths, side, side, side. Okay, and same thing. I typed up a couple of examples, or still a couple of examples of someone using it. So example 1, someone's using this to find the side length. So notice, or this person must have realized that they have side angle side, which is how they knew to use law of cosines. They wrote down the law of cosines formula. It looks like they labeled some of these. Maybe this is side C, so this would be angle C. I think they called this A and this B. So then the next step, they just plugged in 10 for side A, 9 for side B, 10 for side A again, 9 for side B again, and then 47 degrees for angle C. And then I don't know why they did these extra steps. I don't feel like you need basically any of that. If this is what x equals, or x squared equals, then I would just go to my calculator and say x is the square root of all of that. And assuming you are in degree mode, it's going to give you that as an answer. As long as you have the right information and you plug it in your calculator correctly, it's very easy to use. I mean, I guess you can make multiple steps out of it if you want to, like they did, but there's really no need to. Let your calculator do the arithmetic part. Okay, and then to the right, got an example of using it with angles. So it looks like this person realized that they had side, 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 which is when you can use law of cosines to find an angle. So they wrote out the formula, plugged in the numbers, plugged that in their calculator, got an answer between -1 and 1, because that's not how big the angle is, that's what the cosine of the angle is. So then, just like with the law of sines, you have to do inverse cosine of that ratio to get the angle. Same thing, different angle. So the numbers get plugged in slightly different places, but you just plug them in as the formula says. You get the ratio, but if you want the angle, you need to do inverse cosine of that ratio. Okay, and then what would be the easiest way to find the last angle if we got these two? Okay, subtract from 180. That would definitely be the easiest. And then you could also even do law of cosines a third time if you wanted to see that it was consistent. It would still make sure that they all added up to 180. Okay, so you have to practice a few of them, but again, since you don't have to memorize the formula, it's really just making sure you plug them in, the numbers in carefully, and then do the calculator work carefully. Okay, before I show you 2 new area formulas, which is the last part of our first unit of this semester, is there anything that jumps out at you about law of sines or law of cosines you want to get clarified? Did anyone do the ACT class last semester? Or last year maybe? You didn't? Do you remember if you did they talk about this at all in there?
We didn't talk about that much math. Like, we talked more about English and reading, but when we did, I don't remember this and that.
Okay. It's very common one of your questions. Again, it's not ever going to be more than one, but this is pretty much the only place for y'all to see it unless you take a college trig course. So, all right, and then the other two things that get squeezed into this unit is two new area formulas. So, right now, the only way that you've probably ever seen to find the area of a triangle is 1/2 base times height. And again, we don't even make you memorize these formulas, but I will add that I have seen this on the ACT as well. Very easy question if you recognize it. But I will kind of show you where the first one came from, and then I'll just tell you what the other two are. If you have a triangle ABC, which one of these sides would most people call the base? Side what? Okay, or side B, same thing, right? Usually the one on the bottom is the base. So I'm going to call the base B, since it's on the bottom. But the height, since you guys have more trig background now, you have different ways of finding this height. And again, I don't expect you to derive it like this every time. But you could say, well, if I'm looking at angle A, if I'm looking at this right triangle, I could do sine, which is opposite over his hypotenuse, which would be side C. So when B is the base, his height is C times the sine of A. C times the sine of, oops, there. So it's just a, I'm trying to put these both in red to help you see that. That's just a fancier way to say height. But this doesn't have to be the base. The base doesn't have to be on the bottom. Questions are usually rigged for you that way in a geometry class for simplicity. But this could be C, that could be A, and that could be B. And in that case, your base is A. And if you want to do the trig, right triangle trig, you would figure out that the height could be B times the sine of C. And then the only other possibility, which one have I not used for a base yet?
C.
Okay, and then just from pattern, what do you think the height would be?
A times the sine of B.
Very good. 1/2 BC sine of A, 1/2 AB sine of C, or 1/2, I'm going to rearrange these, just AC sine of B. All three combinations. So anytime you have this side angle side, you can just do 1/2 times one of the side lengths you know, times the second side length you know, times the sine of the angle in between those. And again, it's just a fancy height. You guys could figure that out, it's just that you don't have to go through that. I just showed you for the first one. So the book assignment will have you do a couple of those, and usually you guys get a little stumped on that, but then once you figure out what you're doing, it takes 2 seconds to throw it in the calculator. Finally, my favorite, this is referred to as Heron's formula, and honestly, I don't know why they don't teach you this one in geometry, because it is easy to use and super useful. If you know all three sides of a triangle, you can always find the area by doing the square root of s times s minus one of the lengths times s minus the second length times s minus the third length. And the only kind of catch to that is you need to know how to find s. And s is where you add up all three lengths and divide by, what do you think we would divide by? Okay, most people guess 3, but put an X through that. S is not an average. You divide by 2 because S stands for semi-perimeter. Just like a semicircle is half of a circle, semi-perimeter is half of perimeter. I'm trying to highlight that because it's very easy to think it's divided by 3. Now again, we'll provide that formula for you, so it really shouldn't be an issue if you're careful, but very, very quick and easy way to find the area of any triangle if you know it's 3 lengths. And with the calculator, you just plug it in and hit enter and you're done. Okay, so make sure you have that copied down, please. And then if you get out a blank piece of paper, got a few questions from each for you to practice. And before you get too far into there, I would make sure that your calculator is in degree mode. And we've got a couple questions on page 406 and then a couple more on page 413. And I would recommend that you keep out your notes because you don't have to memorize those formulas. So feel free to refer to your notes for the formulas. But go ahead and spend a few minutes starting question 5, see how it goes. I will go over question 5 once I think you've had time to try it. And then hopefully that will clear up anything that's holding you back. And then I will take whatever other questions you guys find in class today. But otherwise, that will be the first part of our practice. Then our plan for, let's see, I will see you again on Friday because this is an A week. So on Friday, I will take the book questions that you had that you didn't have time to get to in class. And I will give you a practice quiz. And then we will quiz over this on Monday of next week. It'll only be like a 20 or 30 point quiz because this isn't really a big unit or anything. Again, we're really doing it for you to be prepared for one ACT question. But of course, early in the semester, your grades have reset. It'll be the only quiz that you have temporarily, so it'll impact your grade quite a bit up front. Go ahead and write that down and start question 5 and see how it goes. Okay, so question 5 is one that you can check in the back of the book. So if you have been struggling on it or you did not come up with that as an answer, then you should probably watch me go over it. Try to figure out what you did differently. Otherwise, of course, we'll just keep on going. Alright, so it asks you to solve the triangle, which means you should be finding all the missing stuff, which would be angle A, side A, and side C. And by the way, technically the directions say use law of sines, but if for some reason you think law of cosines works and you would prefer law of cosines, you can use law of cosines too. I don't really care. But I'm going to try to stick with law of sines on the law of sines questions. Well, the easiest way to find angle A is to just subtract them from 180. We don't have to use something new just because we have it. So, if I subtract the two given angles, looks like the last angle is a nice even 30 degrees. So that's how I would find that one. Now, to find A or C, don't be tempted to try to squeeze in Pythagorean theorem. Pythagorean theorem only works on right triangles. That stuff does not apply here. This is not a right triangle. But if I want to find side A and I realize that law of sines works, then I have to pair up A with the sine of his opposite angle, which I happen to know. And then I have to set that equal to B over the sine of B or C over the sine of C. And it doesn't matter, whichever one you think is going to be easier. Since they gave me B and angle B, that's the information that I have ready to go. So there's the law of sines with the numbers plugged in. Notice I only have one missing variable, so it's ready to solve, and then go to the calculator. Undo divide by the sine of 30 by multiplying both sides by the sine of 30. Make sure you put this in your calculator correctly. And then round. Try not to round till the very end. But it looks like this would be about 14.142. Not degrees. Okay, and then now you have 2 of 3 sides. So again, you might be tempted to think Pythagorean theorem, but that's only right triangles. You can't do that here. You need to use law of sines again, or if you'd rather use law of cosines, then go for it. But law of sines is what I'm going to stick with. Law of sines is just a little bit easier formula, so usually when I have a choice, I go with law of sines. But if I want to find side C, I've got to put that over the sine of angle C. And then I have to set that equal to A over the sine of A or B over the sine of B. And I have all of that information now, so technically it shouldn't matter. Mathematically it shouldn't matter. But I will warn you that technically I did the work to find angle A and I did the work to find side A. And if I made a mistake on one of those or both of those and I reuse that, then it's going to make it my answer C wrong too. So the safer bet is to just use B and angle B again, because I know those are correct. Those were given to me. Undo divided by sine of 105 by multiplying by the sine of 105. And then put it in your calculator. Sometimes you're going to need parentheses around the numerator and parentheses around the denominator to make sure that you are asking your calculator to do the order of operations you are expecting it to, but this one is good to go. And I believe that to be my 3 answers. The last piece of advice I'd give you here, though, of course you should be checking your answers in the back of the book, but do the 5-second check and make sure that your smallest side is opposite your smallest angle and your biggest side is opposite your biggest angle. If either one of those is not true, then there's no way it could be correct. So I did a lot of talking there, a lot of justifying, but at the end of the day, here was the law of sine with numbers plugged in. Solving those were one step, and the calculator did the hard arithmetic part for me. So, okay, so let me leave this up for a few minutes. So if y'all see something you disagree with or something that you're unsure about, I would be happy to clarify for you. Otherwise, I will give you a little bit of time to try the next few.
Mr. Townsend?
Yeah.
In the instructions, it says to round the answers to 2 decimal places. Would
Oh.
that just come to sorry,
Yeah, I should have just done that. I took off the 3rd decimal. I just, out of habit, I always do 3 decimals. We always ask for 3 decimals in AP Calculus because the AP exam always asks for 3 decimals. Well, it doesn't ask for 3 decimals. It expects you to give 3 decimals without it even asking. So I just do it out of habit. Anything else about number 5 while it's up? I'm going to give you a little bit of time to work. Based on what last period asked, I think the next thing that gave a few people issues is remembering how to deal with this degrees, minutes, and seconds. So you just need to remember that a minute is a 60th of a degree. So if you put that in your calculator, well, it's going to be a third. 83 and 1/3 degrees. You need to remember how to change that over, and either A, you need to, let's, keep up with all 7 or 8. Yeah, over there by Trent. Or preferably use the store button to store it in for A. So if you don't know what I'm talking about with that, then just make sure you ask about it when I give you a chance in a minute. Okay, question 8 or 11, either one of those two, giving anybody issues? Question 11? Okay. Okay, so for question 11, again, first part is make sure that you remember how to deal with this degrees and minutes here. So this is the same thing as 83 full degrees plus 20/60ths of a degree. So that's going to be 83 1/3 degrees, or 83.3 repeating. Now, there's a good chance if some of your answers are a little bit off and you're not sure what you did differently, this is probably what it is. Now, for this one, I could understand why you might round this to 0.33, but if you use this rounded amount later, then your other answers are going to keep getting further and further away from where they're supposed to be. So, you really got two options here. Either A, you can keep up with all of these decimals, which is still a tiny bit incorrect, and it's more work. Or you can use the store button, and I don't think we used the store button too much last semester, but I would definitely recommend it a little bit more this semester. Since this is supposed to be angle A, I would actually store it in for A, and then your calculator knows the exact value and it's not rounding at all, so it keeps it perfect and it makes your life easier. Okay, but if I know how big angle A is and how big angle C is, then I can subtract those two from 180. And notice I can just put A because I stored it in there. And then that would be angle B. So on my paper, no one wants to look at 8 or 9 decimals. No one cares about it being that accurate if you're just looking at angle B. But I suspect I'm probably going to use this before this question's over, so I'm going to store it in for B, so I have B to be exact as well. Again, you can keep up with all the decimals if you'd rather do that than the store button. The store button is much easier. Okay, for the side lengths though, now you've got to get out the law of sines finally. If you want to know side A, you have to put it over the sine of angle A, which is fine. I know that and have that stored in my calculator. And then you have to set that equal to B over the sine of B, or C over the sine of C, which is what I'm going to pick because I have those other two things. So in my calculator, it looks like the length of A is going to come from 18.1 times the sine of angle A over the sine of 54.6 degrees. We'll check that. Okay, and I don't think this has come up in any of these first couple questions yet, but you guys need to make a habit out of either doing one of two things. If you do not put parentheses around the numerator and parentheses around the denominator, your calculator is going to do the exact order of operations as you type it in, which is not always what you intend for it to be. If you put parentheses around the numerator and parentheses around the denominator, even if you don't need it, it doesn't hurt anything, but sometimes it does matter. So I did that, and then that would be side A, 22.055. Now again, that's a final answer, so that's why I don't mind rounding it. You just don't want to round and then use a rounded amount. Then, or the other way that you can do this, if you don't want to always put parentheses around the numerator and parentheses around the denominator, if you hit alpha y equals, this first option, I don't think of this one very often, but this first option lets you type it in the way you would write it on your paper. So that is perfectly fine too. It's just that in mathematics, when we write a big fraction like this, we're actually saying, do all this numerator stuff first, then do all this denominator stuff, and then divide. So there's like implied parentheses around the numerator and implied parentheses around the denominator. We just don't write it when we do a big fraction. But make sure you do one of those two things. Either the alpha y equals to make it look like this, or get in the habit of putting parentheses around the numerator and denominator, even if you think you don't need it. Because otherwise there'll be some questions that you're doing right, but you're not putting it in the calculator correctly. Okay, and then the last one would be B. Again, don't be tempted to do Pythagorean theorem here. This is not a right triangle. But if I want to know B, I have to put it over the sine of angle B. I could put that equal to A over the sine of A, but I did the work for those, and there could be a mistake there. It's much safer to go with C over the sine of C, because those were given to me. So in my calculator, I'm going to ask it what is 18.1 times the sine of angle B that I have stored in from earlier over the sine of 54.6. And actually it looks exactly the same as what I just did. Do you guys know an easy way to pull this back up without retyping it all in?
If you press up to it and then you hit enter, like if you press the up button until it highlights blue and hit enter.
Okay, and then it puts it down at the bottom. If you do that, does it let you make changes to it?
Yes.
Okay. I don't use that works fine. The way I often do it, which I don't guess is any better, but you can do second enter and it pulls up the last thing you typed in, and then if you just keep spamming second enter, it just keeps pulling up the last things you typed in. So I don't know. I should not have done that. I messed up my angle B. That's okay. Should have it appear from last class. Or side B. Okay, so if you type that in, it looks like B should be 14.877 at the end. So again, most of your challenge here should just be using the calculator, making sure you're typing it in correctly. Shouldn't mess up the formula because it's provided for you. And pretty easy equations to solve. So. Okay, so I think you've got a couple more of those, and then you have a couple area formulas. Make sure you look back at your notes on that, because those can be easy. And then a couple of word questions. So instead of a generic triangle, some actual application behind it. And then you'll need to skip ahead and then try the same thing with the law of cosines a couple times. And we got about 15 minutes, so please just speak up when you get to one that you need some help on. Short of that, make sure that you try all of these questions between now and Friday, please. So that Friday we can start off class with your questions that you have. If there's any of them that didn't work out for you, that'll be the first thing we do on Friday, and then I will also give you a review/practice assessment to do on Friday, and then you should know exactly where you stand and if you need to study. And then we will move on. Is there a question or two I can help with?
45.
45? Alright, 45 tells us this length is 40. We've got a tree that's almost at a right angle, but not quite, which is actually more realistic. Most trees are not exactly straight up and down, like a lot of geometry questions that you often see. And we know this angle is 30. And so we're supposed to A, come up with an equation that could find the height, and then B, actually solve it to find that height. Okay, well, we could, I'm going to try to stick to law of sines here since this is still in the 6.1 work. So I know that if I want to find an equation that solves for h, I've got to put that over the sine of his opposite angle. These two have to go together. And I have to set that equal to another length I know divided by the sine of its opposite angle. I don't know this length, and figuring out this length would be just as much work as figuring out this length. So I'm going to go with this length of 40 meters, but I have to divide it by the sine of his opposite angle, which I don't know yet. But since I've got two of three angles of a right triangle, or two angles of a triangle, I can just subtract those from 180. It's not a difficult angle to find, at least. And now there's part A. There's an equation that we could solve for the height of our tree. And then part B, to actually solve it, we're going to undo the dividing by the sine of 30. 6. And put it in your calculator. Looks like it's 24.124. That would be meters. Now, I don't have too much to compare it to, but I do know that this 40 meter length was opposite 56 degrees, and the tree was only opposite a 30-degree angle, so I knew that the answer needed to be less than 40. So, short of that, you know, it's hard to know for sure if that's correct, but that's as close as you can get to checking it.
Can you do 47 as well?
Sure. But 45, any other detailed questions about this one while it's up? Anybody else that had a question about it? Okay. 47 is pretty similar, except you do need one more angle, and for that one it does take a little bit more work. So basically we've got two fire stations, which is sounds like a question we had last semester, but it's significantly easier with law of sines, law of cosines. Last semester we were just trying to make it work with right triangles. I know this whole angle is 80 degrees and this much of it's 65 degrees, so right away I'm going to just do the math and say this is 15 degrees. They also tell me this bearing is 70 degrees. And from that, we should be able to figure out the distance from this tower to the fire and this station to the fire. Now, the nice thing about law of sines and law of cosines is you don't have to like wonder what else you really need. Just start writing out what you need, and you're going to figure it out based on what you're missing. If I want to figure out y first, I need to put it over the sine of his opposite angle, which was basically given to me. But then I have to set that equal to another length that I know. They gave me this as well. But I have to put it over the sine of his opposite angle, which would be down over here. So if I can figure out this angle, I can plug it in and I can solve for y pretty easily. What makes this question a touch harder though is you need more angle information, and this is pretty much all you've got to work with. So the trick to this question is a similar trick that we had last semester. If this is a north line and this is a north line, then they are guaranteed to be parallel. And looks like we have a couple different things we could look at as transversals, but if I look at this as a transversal, this angle up here in the top left alternates with this one in the bottom right. They're both inside, alternate interior angles. So if that's 65, this is 65. And then now if I just look at my big triangle, I could take away this angle, take away this whole angle, and that's going to leave behind what the last angle needs to be. It is 30. And then that one's ready to solve. 30 sine of 15 divided by the sine of 30. So the actual law of sines part was really about 10 seconds worth of work. I just needed more angle information, so that's where I have to kind of slow down. And then once I've got this one, it also wanted me to find x. So I could put x over the sine of his opposite angle, and I've already done the hard part of that. It's 135. And then you need to set it equal to another length you know over the sine of his opposite angle. I already did this work, so I'm just going to reuse it. And so it looks like this other length, x, would be 30 sine of 135 divided by the sine of 30. Let the calculator handle that. So that would be your two distances. I think you need to use I'm not 100% sure, but I think you need to use a similar trick on 48. Again, it's not often that you need to use those parallel lines to find another angle, but when you do, there's usually not a good substitute to that. Okay, so please try the rest of those. I do maybe recommend that you take a picture of page 406, 407, and 413, 414, so you could maybe do those during advisory. And if your 9th grade has a assembly today, but I think everybody else doesn't. But I will take any of the questions that you have from that first thing on Friday, so please have tried all of those. Have a good day.